my next video. More of the same, graph each of the following. First thing I want to do, rewrite that to slope-intercept form. So that's negative 4y equals negative 16x minus 12. Divide everybody by negative 4. And so that gives me y equals 4x plus 3. So my y-intercept is 3, and my slope is 4, which I will view as 4 over 1. I want my slope as a fraction, which will tell me up 4, right 1. So y-intercept 3, 1, 2, 3. Plot that point, green, so we can see it. Then, counting from the y-intercept. And a common mistake is students will go back to the origin and start counting from the origin. Be sure you count from the y-intercept. And so it says up 4. So up 4, 1, 2, 3, 4. So up 4, right 1. Right 1, and so I'll just put a corresponding tick mark down here. And then there's my graph, there's my other point. Connect the dots, and we have it. Like I said, that's my favorite way to graph. Next problem. Again, this one isn't particularly special, but again, they throw the function notation in there. If the function notation bothers you, just replace the function notation with y. And if we really want to be specific, that's 2/5 x plus 0. So the y-intercept is 0. My slope is 2/5 up to right 5. You can't see that. Up to right 5. So y-intercept 0, so it's crossing at the origin. Then up to, that was supposed to be in blue, up to, and so 1, 2. There's up to, right 5, 1, 2, 3, 4, 5. There's going to be my new point, and let me just go ahead and put the corresponding tick marks down here. Connect the dots, and there's my graph. And let's graph one more time. There's not a y, so I'm going to head solve for x. And so I'm going to have 2x equals 8. Divide both sides by 2. X equals 4. And then you just say, oh yeah, I remember she told us something about horizontal and vertical lines. She told us to memorize a fact, and I can't find the piece of paper with the facts on it. There it is. She told us that, and she underlined it. Fact. X equal a number is a vertical line with undefined slope. So the minute I see that, I go ding, 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 ding. X equal number, vertical line. And what that 4 is telling you, and I've been a lazy person all the way along. I should have been labeling my x and y axis all the way along, so you can take off teacher points for me that I haven't been labeling the x and y axis. But what that x equal 4 is telling me is where it crosses on the x-axis. That's crossing at x equal 4, and so this in green, so we can see the difference there. There's my line, x equal 4. So if you remember those little facts, x equal number is a vertical line or y equal number is a horizontal line, when you encounter those things and you have to graph it, the graph becomes very easy to do if you remember those two basic facts, that y equal number is a horizontal line with slope 0, y-intercept of the number. X equal number is a vertical line, slope undefined, no y-intercept, and the x-intercept is going to be whatever the number is. Okay, next topic within our thing about lines. Parallel and perpendicular lines. So I got two graphs there. If we look at this first one, the thing we can note here is that they both have slopes of 3. And then those lines appear to be parallel. They appear to never meet. That's our first fact. Two lines are parallel if and only if their slopes are equal. Equal slopes means parallel. Parallel means equal slopes. Over here, these guys are perpendicular. They meet at right angles. Now notice here, this guy has a slope of 1/2, and this has a slope of -2, which I could write as -2/1. The relationship here between those two slopes is, notice they are negative reciprocals. What we mean by negative reciprocals is the numbers are flipped from each other, and one's positive, one's negative. That's what we mean by negative reciprocals. One guy's positive, one guy's negative, and they're flipped. These guys are perpendicular, and that's our fact there too. Two lines are perpendicular if and only if their slopes are negative reciprocals of each other. You should memorize these two little facts. They will come up later. Now, comment about your calculators. I very carefully made a computer graph this, and I made sure that the computer measured your x and y axes, measured my x and y axis in the same way. The standard setting on your calculator, if you do Zoom 6, the standard setting on the TI-83, 84, the standard setting does not measure things in the same way. That they measure the x-axis a little bit longer than the y-axis, and you can see that on the screen. The x-axis is going to be longer than the y-axis, but yet they still measure the x-axis from -10 to 10 and the y-axis from -10 to 10. So they aren't measured the same way. So if you were to graph these things on your on the TI-83 or 84 using the standard window, Zoom 6, they wouldn't look perpendicular. And so I just alert you to that fact that if you graph it and say, well, gosh, those things don't look perpendicular, that's because the calculator has distorted them. Okay, we're going to use these facts later, and then we're going to move on to one of the more important topics in this section, writing the equation of lines. If you're going on to Calculus 1, because you're a science or an engineering major, or you're going on to survey of calculus, this topic right here, writing equations of lines, your instructor is just going to point blank expect you to be able to do. This isn't one of the things where they're willing to really review it a lot. They just expect you to be able to do it. So, before we can talk about writing equations of lines, and what I mean by that is we're going to be given some information, and then it'll say, find the equation that does this. You know, what equation will embody this information? Before we can do that, we need a couple more formulas. The equation with the slope m and passing through the point x1, y1 is given by y minus y1 equals m times the quantity x minus x1. That's the point slope formula line. And that will be one of our primary tools when we're asked to write equations of lines. And that's pretty much the only time we're going to use that equation is when we're finding equations of lines. Then another equation here, general form of a line. Every line has an equation in the form ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b are not both 0. In MyLabs Plus, although we're not doing plus anymore, we'll just say the computer. The computer also uses the convention that a, b, and c are integers, meaning no decimals or fractions, and a is positive. The only thing general form of equation of a line is good for is answer keys. It makes the answer look pretty without having any little fractions in there or anything like that. That's the only thing it's good for. Now, I will not ask for general form of a line, but the homework does. And so in the homework, when they ask for a general form, that just means everything is on, they've got a 0 on one side, everything else on the left. A, B, and C are integers with the A positive. But I will never ask for it. Now, in some of the videos that I've posted in Folio, they have the C on the other side. That just depends on what that particular author likes. Whether the C is with everybody else or you have the C instead of the 0, that just depends on what the author likes, which is another reason why general form is useless, because it is not completely agreed upon. But if the homework asks for it, give it. Okay, so how are we going to do this equations of line things? Writing equations of lines in non-vertical and for non-vertical and non-horizontal lines. And that's what we're going to be doing, non-vertical, non-horizontal. If you were asked to do vertical and horizontal, well, then you're just going to remember the two facts we have. Vertical lines are x equal number. Horizontal lines are y equal number. That's all there is to non-vertical, to vertical and horizontal. We're going to do non-vertical, non-horizontal. But if you're asked about horizontal, just remember y equal number. If you're asked about vertical, x equal number. So our very general steps. 1, find the slope. Here's where the problems will differ each time, how you go about finding the slope. But that's the common first step, find the slope. 2, substitute into a point slope form of a line. 3, rewrite to the desired format. Make the answer look like what they want. So let's start practicing these things. Write an equation for the line described. Express your answer in point-slope form, slope-intercept form, general form. Okay, so we have a slope of -2 passing through the point 4, -5. So 1, find the slope. These are our favorite problems. It's given m equals -2. Then I use point slope. And so y minus y1 equals m times x minus x1, because you know all the pieces here. The point is giving you the value of x1, y1. So point slope form of a line, y minus -5 equals -2 times x minus 4, or that's y plus 5 equals -2x minus 4. Now notice here it says express your answers in point slope form, slope intercept form, general form. They want us to express the answer every possible way. Now that isn't quite what it is on homework. Usually they pick 2 ways. We're just going to do all 3 ways each time for the practice. When they say slope intercept form or point slope, there is point slope right there. Do not distribute it. There's point slope. And like I said, when they say point slope, give them that. If you distribute it and they wanted point slope, they will count it wrong. Then getting our other forms, let's go for slope intercept first. My whiteout is giving me issues. So slope intercept form. So I'm going to distribute first and get y plus 5 equals -2x plus 8. Then subtract the 5 from all the parts, and so y equals -2x minus 3. And there's my slope intercept. And we'll end this video because I only have 30 seconds left. And on the next video, we will rewrite to general form.